so that people miss, they can watch them.
Wait, you do?
Yeah.
Wait, so they would hear us talking?
Oh, yeah. And isn't that exciting? Okay. Today, we have a lesson, and it's not a long lesson. I don't think the lesson will take us long, but it's an important lesson. As Ms. Sparks can attest, this is something that will come up again and again and again and again and again and again, the distributive property in math. It's not going anywhere. It's pretty easy. The lesson's short, it's pretty easy, but you are going to do this. You are going to be reminded that you have to use the distributive property like 55 times a year in math for the rest of the year, but it's conceptual. Would somebody hand these out from some kind of soul? Thank you so much. I'm joking. Hand them out now. Okay, so.
Just a prank.
Hey, go! Whew. Oh boy, kind of felt like I was 14 then. My voice just cracked. Well, whew. Okay. Late bloomer currently. Okay, so attention, s'il vous plaît.
No.
Non, nous parlons français. Okay, so I actually, and I'm not making this up, I have a nightmare that I have to teach, and this is completely true. I have a recurring nightmare that I'm teaching a math class in French, and I don't actually know what's going on, and all the kids are asking me questions in French, and I get really stressed out, and I wake up all like, it's just a dream. It's just a dream. My class speaks English. Thank you. Anyway. So, anyway, I want to start with a simple bed mass question. I want to look at this example right here. And what does bed mass tell us we should do first here? Yes, ma'am. Brackets. And in this case, what's in the bracket? So what would my next step be here? I would write this as 2 times, what's 2 plus 3? 5, good. So I write this as 2 times 5. And 2 times 5, of course, is equal to 10. Okay. The good news is this, that's completely right. That is correct. Nothing wrong about that. So, we know from grade 8 math, and I think you start bed math what, in grade 7? Is that true?
Yeah.
No more.
More. 6 to 7.
It occurs to me that I think I just pulled a number out of the hat. But anyway, point being, okay, guys. Thank you. So we've been doing bed math a long time, and this works. This is totally correct. All right. So we can think of this as, we can think of this visually like this, that we have 2 groups, and those groups look like this. We have, I'm just going to use some color, but kind of 2 things added to 3 things, and we know all together that's how many things? 5. So we can think of it as 2 groups of 5 things. One, 2, 3, 4, 5. And of course, what would 2 groups of that look like? It would look like this. 1, 2, 3, 4, 5. 1, 2, 3. And that gives us the number 10. Does that kind of make sense? So we can think of this just visually as this question is asking us, what would 2 groups of 2 plus 3 look like? Well, we know that 2 things and 3 things, that's just 5 things. And 2 groups of that's going to look like this, and that adds up to a total of 10 things. I'm not trying to confuse you here. I'm just trying to show visually what we do with bed maths, right? The first thing we did is we looked at this as 2 and 3. And we know that 2 and 3 together is just a group of 5. And then we wanted 2 of those groups, so that's 5 and 5 more, and that gives us 10. That makes sense. I know that I sometimes struggle with these kind of visual representations. In the next couple days, when we're done with this, we're going to look at something called algebra tiles that you may or may not have used in grade 8, but it's a way of kind of visually showing some of the math we're doing. This is kind of a really simplified version of that. But I want to suggest something. If we know we have two groups of this, could we show that by doubling this first and then adding them together? And what I mean is this. We can think of this as a different way. This really means two groups of two plus three. Two groups of two of one thing and three of a different thing. It is okay for us like this. We can think of that as one group of two and another group of two. And one group of three and another group of three. We don't have to combine these first. We can double them first if we want. And then obviously when I combine them still, how many things do I have? 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We still have 10 things. Yeah. Oh. You don't, if you don't find this helpful, you don't necessarily have to grab it. That, honest to God, if that just confuses you, you can leave it off. I'm just trying to give a visual representation for what we're doing mathematically, where this represents what we normally do with bedmaths. We do the 2 plus 3 first. We say 2 plus 3 is equal to 5, then we double. And we say 2 times 5 is equal to 12. I understand that. I understand that. But this second way says, well, we could just double this whole thing. And if we double this whole thing, then we had 2 of the green ones doubled, which is now going to be 4 of the green ones. Does that make sense? And we had 3 of the red ones doubled. That's now going to be 6 of the red ones. And that still adds up to 10. So one way follows bedmass. One way does it differently than the normal order operations. It doesn't follow bedmass, but it's still mathematically correct. Why would I do it a way differently than what we've already learned? Why do that to myself?
Just in case you have a variable.
Ha! That's correct. That was going to be my big thunder moment. We stole it. But yeah, if we have a variable, I want to give you an example now. 3 times x plus 2. All right. Everyone see this? Now, the problem with this is that bedmass tells me I do what first? Good, we do the brackets first. So we go into the brackets. Great. What's x plus 2? Nope, that'd be x times 2. What's x plus 2? Nope, that would be 2x, which is multiplied. So if it was x times 2, we'd get 2x for sure. But this doesn't say that. What it says is x plus 2. We can't do that unless we know what number x is. And we don't know what number x is. It's a variable. It could be any number. So here's the problem. We can't use bedmass to simplify this, or to expand this rather, because we can't use bedmass because we can't do what's in the bracket. And if you can't do what's in the bracket, bedmass breaks down, right? Because what's the first letter in bedmass? Great! Buh! And we can't do the buh. So, here's what I want to suggest. We can think of this as 3 And then what color do you want to use for x? Doesn't matter. Okay, so we've got an x. And then I'm going to use green for the numbers. And we've got two numbers. How could I write that? Well, if this is going to be 3 of all this, how many red things will I end up with?
1.
No, we're multiplying by 3. So how many of them will there be?
3,
3. How many green things will I end up with?
6,
6. Good. So what we'll end up with is a red, a red, and a red. And remember that was an x. And then have 2, 2, and 2. And each of these is just a digit. It's just 1. And what we end up with is how many x's? Good. How many numbers? Yeah. Yeah, well, this is how many x's? If there's no number in front, we know the number is 1. So this is 1x, and then 2 actual numbers. 2. Now, are we going to draw a stupid little picture like this every time we go to a question?
No.
No. Because they'll get pretty complicated pretty quickly. So I want to show you how we would normally do this question. So let's rewrite the question. And what we really say is this. We don't have to follow BEDMAS if we use something called the distributive property. That's the title of this lesson. The distributive property. What does it mean to distribute something? Have we distributed something in class today?
Knowledge.
Well, hopefully, but yeah. The papers. Okay, yeah. And by I mean Alex, distributed this handout. When he distributed it, what did he do? He handed it out. To whom? To everybody. Everybody in the class had to be given a paper. Does that make sense? That's what distribution means. Distribution means you take one thing, you get more than one copy of it, because you have to give it to everyone in the class. Does that make sense? That's what we're going to do here. We are trying to multiply by 3, but we have to distribute that to the whole class. In this case, the class is all the terms in this bracket. How many terms are in this bracket? 2. Both of these things are going to be multiplied by 3. And I usually draw some arrows to show me what I'm doing. And up here, I will often color code them. That obviously won't be as practical for you. But so first, we're going to multiply 3 by x. What will that give me? 3x. 3 times x equals 3x. Is that comfortable? 3 times x is 3x? Tell me if something's confusing. It's good. I'll take that. But we have to distribute that 3. We have to hand the 3 out to everybody in class. So the 3 also has to be multiplied by what? By the positive 2. And what's 3 times positive 2? Great. Positive or negative? Good. And remember, just like when we collect like terms, the sign in front of a number goes with it. The sign in front of a number goes with it. So this is 3 times positive 2. This was 3 times positive x. So we do have that kind of sneaky rule where the first number, we don't write the plus sign if it's positive. But we know it is. And so altogether, this equals 3x plus 6.
How do we write it's negative 3x?
I'm so sorry. How would I write it if it were negative?
Yeah.
Sure. Take a look. Don't write this. Let me just show you. It's on the next page. But this question could have been negative 3 times negative x minus 6. And that's how we would write it. Okay? Now, again, don't write that because we'll get to examples with negatives in it. But just to answer your question. I'm glad to do
We just write stuff on it.
Yeah, I
This
hope.
makes sense.
I actually haven't really done a survey about that yet. But in general, do you guys find that you like the pre-written note that you just kind of fill out?
Yeah.
Yeah, that's a better structure. Because I do worry sometimes that there is advantage to writing things out. But I think if you're spending a whole bunch of time writing, we call this the distributive property, it means anchor, blah, 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 blah. I feel like that's not the part that's important. I feel like the math is the important part. So anyway, that's my thinking. So we call this the distributive property, and we're just going to do a few examples. All right, we're just going to do a few examples. So, and then we'll do two separately. So we said in the distributive property that this 5 is being multiplied by this bracket, right? When we put a number next to a bracket, that means multiplication, right? So there's no sign shown because, again, mathematicians are lazy. But we know that this means multiplication. Now, that's because I don't style it. I wake up and as I'm leaving the house go, oh, I can't leave like this because it'll look like this, like just off straight in one angle, like going all fizzy. And so then I quickly like get some water and go like this, and then go, well, that looks better. And then I leave. That's my usual.
That's how you get your notes.
That's right. This I'd like to say this doesn't just happen, it takes hours of work, but actually this basically just happens. Hours of work would probably be helpful. Okay, so this 5 needs to be distributed to everything in the brackets. Now for now we're sticking with simple ones. 2 things in the bracket. How many things could be in the bracket? Yeah, could I put 20 things in the bracket and make you sit there and multiply all day long?
Yes, you could.
Sure, I'm not gonna, but I could. Okay, now I'll tell you right now, if you come into my 3U math class right now, they're doing some questions that have like 7 things in the bracket, and I have to multiply them all and not screw up. But even that, it's just practice. It's just being careful. Okay, yeah, we'll get there. So this 5, what's the first thing it's going to be multiplied by?
2x.
Yeah. What is 5 times 2x? Yeah, is everyone comfortable with that? 5 times 2 is 10, and there's just still an x there. So 5 times 2x is 10x. What is the next thing that 5 has to be distributed to? Yeah. And what is, and let's be careful, negative 15. That's important, right? It's important that this 5 is positive, this 3 is negative, and a negative times a positive will be negative. And listen, it will be the most common mistake that people just miss negative signs or invent them where they don't exist, but more often miss them. That's the most common mistake we make when we do this kind of math. I'm going to rewrite this in blue just to show the answer cleanly.
I'll get this.
Does everyone see why I'm color coding this? Just to show us where this number comes from
Oh.
and where this number comes from. So I'm not color coding because I wish it were Christmas, though. Wish it were Christmas. Okay, let's look at this example. Could have made the font a little bigger on that. That's okay. Okay, now again, we have 3 multiplied by negative 2x. Negative 2x minus 1. So what's the first thing we multiply the 3 by?
Negative 2x.
Okay, good. Don't tell me the answers. Thank you. Okay. Quickly now. 3 times negative 2x. Is that going to be positive or negative? How do you know? Okay. What's the digit going to be? 3 times 2. Yeah, so it's going to be negative 6. And then does it have an x? Yeah, how many of them? Just 1. Just an x. Okay, good job. Now, what's the next thing we have to distribute? Yep. 3 to the 1, 3 to the negative 1. Good. Now, again, let's go through. Positive or negative? How do you know it's negative? Yeah, because it has 1 negative sign. It's a positive times a negative. What is 3 times 1? 3. Good. Do you see that process I walked you through every time we answered one of those? Take your time, be slow with it. Ask yourself, is this term going to be positive or negative? Write down the sign. What's the digit going to be? Just worry about the numbers. Then think about variables, and we'll talk about that more in the next set of examples. So this simplifies to just negative 6x minus 3. Again, I'm just rewriting the same thing. I'm just rewriting it all in one color because otherwise it feels kind of weird. Okay? I want you guys to take a couple of minutes and try these next two examples. 4 times x plus 3, 2 times negative 3x plus 5.
Yeah, let's start on the homework.
Yeah, you bet.
I'm done. Sure, what sign? But that's not 4x22.
Not mine.
Because the sign in the middle, that's the sign in the middle. That's plus sign. So it's gonna be plus or minus. These terms will always have to be something. Oh, my. Yeah, that's right. So here, it's gonna be positive, so we have to put plus. Otherwise, I would think that's all one term. Does that make sense? No, just because.
Is that right?
Yeah, there is. This time here.
Negative 6x. That one, 8x plus
That's great.
4x.
I mean, if you feel comfortable, yes, but I am going to walk you through that because it's got variables up front now. All right, let's see. Go ahead. You got it? Okay. Yeah, good job. Can I see? Yeah. That is the new wireless letters they put in every room.
Right.
Yeah, so they put one in every room now, so the.
Is that why there was a hole there the one day?
That's right.
Yeah, I thought a mouse was gonna come down and just fall. Hey, look, there's no hole in it.
Yeah. So in theory, we should no longer have.
Really?
Can I
Really?
check- you are-
Oh, I have all.
This is good. You're right. Completely right. You just can't add those together because they're not right choices. So you have the right answer, you know, and then you did something. Yeah. So. Beautiful. This is good. Likewise.
I gave him too much.
My mom is.
Give me a second.
You're reading.
Oh God, you're trying to hurt my eyes.
I know, I looked at her paper, I was like, huh?
I'm just saying they look good. I can't see that.
Yeah, well, on the side.
You do write really small. I'm impressed. It shows like great like hand-eye coordination.
I do it in English.
Okay. I almost look like I like the 4x.
What do you think?
No, I'm okay. I like 4x. Then 4x it is. Also, it's the right dish. Okay, guys. Let's take a look up here. Let's take a look up here. And again, I have an advantage over you guys in that I can kind of nicely switch colors as I go, which I do think helps. Do you know that I have been I've been applying to a grant for years, and I'll probably never get it, but to get a whole classroom set of these guys, like with the stylus and with the pen. So that wouldn't that be amazing? Yeah. Yeah, I can't seem to get it. Yeah, it would be a lot of money, to be sure. Yeah, well, that's the issue too, right? You'd have to get insurance on them for sure, and insurance on a classroom set would not be cheap. Yeah, it's so let's take a look at this. The first multiplication I have to do here is what? Well, we take what's outside the bracket. It's going to be multiplied by each term in the bracket. So we're going to get 4 times x, and that gives me 4x.
Are you saying I have to draw this?
I don't know. Give me. I'm not. Not thinking about it right now. Okay, and then we have 4 times positive 3, which gives me what? Good. Now, the natural instinct here, and it's a good instinct. It is a good instinct. It's the right kind of thinking, is to want to say that this is 16x. Right? That should be what you're thinking. You should be compressing this as much as you can. Unfortunately, that doesn't work because we have to remember that we can only add like terms. And is this a like term to that? No. So this is where the question ends. And I'm going to write it out in blue just because, again, I think it looks a little nicer to have it all in one color. But the colors show you where that comes from. Sorry? Any questions about that?
Yes. I was thinking.
That's not a question so much as just you telling me you weren't paying attention. If you're not paying attention, catch me after and I'll be happy to clear you up. Okay, what about this example? How do we do it? Walk me through it. Yes, sir. Okay, so -6, which gives me positive and -10. Okay, so 6 plus 10. I forgot the x, okay. But if I put an x in there, now we're good? Great. That looks good to me. Well done. Oh, I want blue. Yeah, that looks great. Good job. Missing that x is another one of those most common problems. So just always take your time with it. What's the sign going to be? What's the number going to be? Then think, what letters are there? Does that make sense? Just think of it one thing at a time. Sign, number, variables. And in the next example, exponents on the variables. That's the next thing we're going to talk about. So I titled the next bit, Don't Forget Lesson 2.2. Because if you're struggling with this, go back and look at the note we took on 2.2. It'll remind us how we multiply 2 powers, which is, obviously, we're going to go over it. But I'm just saying that if the main skill here is giving you trouble, we can go back and work on 2.2 together. Do some of that homework. Make sure we're comfortable with that. So here, what term is outside the brackets? What term do we have? 3x. So now, when we distribute this, and remember, distributing it is like handing it out to the class, right? When we distribute papers, we give everyone in the class. When we distribute 3x, we're going to multiply it by everything in the bracket. We're going to multiply it by the 2x, and we're going to multiply it by the 1. So let's think about this first one. 3x times 2x. How do I approach this? Yeah? Positive 3 times positive 2. So the answer is definitely going to be positive or negative? Positive. 3 times 2 is 6. Great. Now, what's x times x? What do our power rules tell us about that? No. X squared. Right thinking, but we got to put that 2 in the right place, not in front. When we multiply powers, we add the exponents, right? Does everyone remember that? I'm actually going to show that here. I'm going to say it's x1 plus 1. because it's the exponent from this x added to the exponent from that x. So x times x gives us x squared, but I'm showing you why we do that, right? Remember, we add the exponents when we multiply x by x. And obviously, that's going to give us 6x squared. What's the second multiplication we have to do? 3x times positive 1. Now, we have a positive times a positive, so the answer is going to be, bless you, positive. 3 times 1 is? I think you do. 3. And we have an x on the outside with an exponent of 1. Is there any x here to change its exponent? So it's still just going to be x to the exponent 1. Oh, that's my...
So it's simple.
With a bit of practice, you'll find these very simple, I promise. But it will require a bit of practice. That's it. Yeah. Perfect. Well done. Okay, let's try one more example. Oh, how many terms in the bracket here? Shh. How many terms in the bracket here? 3. 1, 2, 3. How many terms will there be in our answer? 3, because we have to distribute this to each of these terms. So there'll be 1 term for that multiplication, 1 term for that multiplication, 1 term for that multiplication. If there's 3 terms in the bracket, there's going to be 3 terms in your answer. So, what is outside the bracket in this case? 4x squared. Good. All right, what's the first multiplication it's going to do? Good. Okay. Now, again, this is how I want you to think through these every time. Outside the number is positive. Inside the number is positive. So the answer should be positive. Good. Now think numbers. 4 and 2 gives us 8. Okay. So it's positive. The digit's going to be 8. Now, they both have x's. So we're going to have x's. What's the exponent on the bracket outside? 2. The exponent inside is? And what do you do with exponents when you multiply powers? We add them. Now, by the way, would you show this middle step every time once you get good at this? You know what? I'm doing my best. How's that? Okay. What is 2 plus 2? 4. So this gives us 8x to the exponent 4. Is everyone comfortable with that? The next one? Sure, but I want you to go step by step. I don't want the answer.
4x.
Okay, shh. Step by step. So first things first, the number outside, positive or negative? Number inside, positive or negative? So it's a negative times a positive. What's the answer going to be? Negative. 4 times 2 is? Oh, why am I putting that there? Negative 8. And now we have x's again. What's the exponent outside? The exponent outside is 2. The exponent inside is 1. And you're totally right. That gives us in total negative 8x to the exponent 3. Good job. Somebody want to try the last one? Yes, sir. Very good. So we have 4x squared times positive 1. What's that going to give me? $4x. Yeah, very good. Anything times 1 is just itself. Whoa. It's going to drive me crazy that that's not green. So, Sorry, if that's not green, it'll make me feel crazy. And if they're not twos, it'll make me feel crazy. I think I'm doomed to feel crazy no matter what. There we go. Okay. Oh! I'll beat you up. Do you want to be beaten up? Okay, then be quiet. Okay, those 4 examples. Hi, Miss, whoever. Let's say Miss Sargent. Okay, there's 4 examples down below. I want you to try them out. I'll come around and see how you're doing. Be careful with positives and negatives. Make sure you're adding your exponents when you multiply polynomial terms. It is a fun one. All right. Come on. Yes, ma'am. Right? I want you to do this first, and I do want you to remind me about that. Is the bottom heading? Squared. No, it's rainy.
When did you take them out?
This is totally like 100% right. Usually you can write it as negative. Plus or negative. That's, I don't understand. I guess I'm asking you then. Yeah, and we'll do any case where you're talking to language. That there. So what I mean is this. Plus or negative. This is wrong. That's one of those things.
We're in the entire house.
But again, I can't stress on what you've written there. Bring it like this. This is how right. Or you want to do it in the thing with this right. Just one at a time. So let's do this together. Start with this and draw that. And now, everyone has questions. You're going to think about the sign, the numbers, and then what letters do we have? Sign, the numbers, A's, right? The rule equal sign. So the sign, positive and negative.
Do that
Good. Yeah, exactly right. Now the number.
This has to be a 3.
Now think that we have a to the exponent of 1 outside, so a to the exponent of 1 inside. They can get a. Very good. A squared to the exponent of 2. Good. Now we have a b to the 1 inside. Nothing's changed. Does that make sense? Try the next one without a lot. Talking great. Fantastic. Very good. For the last Oh, the only thing I don't like is that 6. The number in front. What should the number in front be?
Let me see. Let me see your but other than that, it's just
I think like
Does that make sense?
more.
That's a lot of heat out.
That's supposed to be 4. Leave a question again.
A squared.
A squared. That first one is not like it's supposed to be 4.
Okay, if I can, I'd like to go through these examples together. Let's make sure we're all watching, paying attention. Let's make sure we're all watching, paying attention, and then listen. Look at me. Okay. Be quiet. So, this is such an important concept. Like tomorrow, we're not going to have another lesson. Today, we're just going to have a couple activities. Tomorrow, we're just going to have a couple activities that reinforce this. Again, this is pretty straightforward stuff. I hope you find, gentlemen, do you mind just... It's pretty straightforward stuff, but it's really, really, really important. It's a foundation of math. This idea is one that is really foundational. It comes up again and again and again. So we're going to take our time. We're going to do lots of examples. We're going to make sure you get really, 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 really good at it so that it seems easy. So with that in mind, and what I want to stress is every single time you do this, especially at the beginning, we just take our time and talk ourselves through all of the components. So in this case, the term outside is negative 2x. So first we think about sign. This is a negative times a, so it's going to be negative. Then we think about the number. This is 2 times 3, so it's going to be negative 6. And then we think about the letter. This is x times x. X to the exponent 1 times x to the exponent 1 will give us x to the exponent 2, because we add those exponents. What's the next thing I have to do here? Next thing I have to do here. Yep. Very good. So let's walk through it again. Sign, positive or negative? Negative. 2 times 5 is? And how many x's here? Yeah, just the one from outside. All right, so that should be negative 6x squared minus 10x. Over here. How many terms in the bracket? How many terms are going to be in your answer? 3 is correct. 25, less correct. Okay, let's start with this 5x. The first thing we multiply it by is negative 2x squared. What will the sign be? Positive or negative? Negative. 5 times 2 gives us 10. And x times x squared gives us what? Yeah, we add those exponents. So x times x squared is x to the exponent 3. Next, we have to do that 5x times positive 3x. In this case, positive or negative? Positive. 5 times 3 is 15. And how many x's do we have now? Yeah, it's x squared. Because what do we do with those exponents? We add them. X to the exponent 1 plus 1 gives us 2. And what's the last term here? Sorry? Very good, negative 4. And again, positive or negative? Negative. 5 times 4 is 20. And how many x's do we have now? Just the one from the outside. So that gives us 10x cubed plus 15x squared minus 20x. Okay, the last, yes?
I'm just wondering, does not get to a point where you don't use numbers, you just use the X letters?
Well,
X
I-
plus 8.
I mean, you're at that point now where you have to use both. Is there ever a case where it's just letters? No. No, math is at its foundation about numbers. It's about using numbers to explain things. Okay, last 2 examples. But listen, these trickier and they point to what I'm talking about. When you do a question like this, first of all, how many terms in the bracket? 3. How many terms are going to be in our final product? 3 terms. However many terms in the bracket, that's how many you're going to get. Because again, it's distributed. We're taking this 2AB and we're handing it out to everybody in the class. Handing it out to each term in the bracket. And for each one of these, we're just going to take our time and go slowly because it's easy to make mistakes. So we start with 2AB times what? Negative 3A. Now, here's what we do. Keep. You just want to go one thing at a time. You're going to talk about the sign, then you're going to talk about the number, then you're going to talk about each letter individually. So, first let's talk about the sign. We have a positive times a negative. That's going to be, it's going to be what? Positive?
Negative.
Is there such thing as -1?
Negative. Good. Then we have the number. What's the number in this case? Great. Oh, well, that's interesting. Okay, shh. You're right, but I want to go slowly. Now, we have to think about the letters. What 2 letters do we have? A and B. So let's think about A first. What's the exponent on A outside? What's the exponent on A inside? Together that gives us A to the exponent 2, A squared. What's the exponent on B outside? Is there a B inside? So it stays the same. So the first term is negative 6A squared B. Listen, we want to make sure we all have the same answer on this one. We want to go slowly and make sure. I know it feels like I'm belaboring this, but it's important. What's the next multiplication that happens here? What's the next? Yes, ma'am. Very good. Ms. Sparks, can I bother you for this one? Yeah. No, not you. She's also Miss Sparks. What's the sign going to be on this one? Positive or negative? Good. How'd you know? Negative here and a positive there, right? What will the number be? Very good. How'd you get that? Very good. That's right. Now, let's talk about A's. What's the exponent on A outside the bracket? 1. Are there any A's in this term? So is it going to change? So we'll still just have an A. Now let's talk about B. What's the exponent on B outside the bracket and inside this term for a total of 2? So we get B squared. Does that make sense? Okay. And what's the last term we have to multiply? Hello? There we are. Last term we have to multiply, yes, sir? Very good. So, sign, positive or negative? Good. Somebody else, who can tell me the number on this one? Jacob, you got the number on this one? We're doing 2AB times 4AB. 8? Yep, and then the A's? Very good. A squared and B squared, because we have A times A, that's 1 plus 1 is 2. B times B, 1 plus 1 is 2. Good job. I'm going to leave the last example to be how we start off tomorrow's class, because it's good to have a little reminder. You want to do the last one now?
No, thank you. Please don't.
I'll do the next one in class tomorrow, though certainly if you want to check your work with me now, I'm happy to do that. We'll do the last one tomorrow, like I said. Nope.